Yeah, so the focus of my dissertation is on vulnerability of agricultural systems. We know that weather variability and extremes are expected to increase as a result of climate change, and agriculture is one of the sectors that is highly dependent on rainfall and monsoons, and as such is highly vulnerable to these extreme weather events. To this end, my dissertation looks at understanding the factors that drive the vulnerability of agricultural systems. Yeah, our approach is twofold. So first we define what a vulnerability is, and then we also construct a methodology to capture vulnerability of an agricultural system. The idea of capturing vulnerability comes from some of the topics in the literature on examining poverty. For example, in economics, vulnerability to poverty is defined as the likelihood of an individual realizing an income that is below a particular reference level, such as a poverty line. So analogously, we define vulnerability of agricultural system as the likelihood of falling below a particular threshold. Now, this threshold can vary according to what the researcher is interested in. For example, this threshold could be the past 6 years average yield, or it could be something of 60% of this yield, like they do it in the crop insurance programs, like in India, for example. We use this indicator of vulnerability, and then we apply it to a panel data from India of agricultural districts as well as farm level data. Our indicator is new in the sense that it first of all captures two important dimensions of vulnerability. Firstly, it captures the likelihood, that is the probability of a particular agricultural system being vulnerable, that is falling below a particular reference level. And secondly, it also captures the yield gap, or how far below the threshold you are. These are the two main contributions that come out of this methodology that we construct to capture vulnerability. I'll summarize the results in 4 points. So first of all, what we find is the timing and intensity of the extreme weather event matters. Extreme weather events in droughts and floods are the most common drivers of vulnerability in Indian agriculture. Moderate or normal weather events do not impact vulnerability significantly. The timing also matters. What we find that at what point of the crop growth process does that event occur? Is it during the reproductive phase or the vegetative phase? What we find is vegetative phase does not have a significant impact on vulnerability, but an occurrence of an extreme weather event, for example a drought, during the reproductive phase has a very significant impact on vulnerability. That is, it increases vulnerability of the agricultural systems. We also find that agricultural households are extremely dependent on crop yield growth as the main source of income. So any decline in crop yield growth, or for example increase in vulnerability to crop yields, is directly related to vulnerability to income. What we also find is that vulnerability of crop yields to weather extremes also explains vulnerability of households to poverty. This is primarily because most of the rural households in India are heavily dependent on agriculture as a source of income, and therefore their vulnerability in terms of crop yields falling below that particular reference level also explains them falling below that poverty line. The final two results are related to adaptation. So what we find is that irrigation and to an extent high yield variety seeds are adaptive mechanisms in that they increase the resilience of agricultural systems to these weather extremes. Another important finding from our study is that crop diversification is an important tool that farmers employ to mitigate losses in crop yields, and as such increase their sources of income and to cope with these weather events. So this topic is important in the sense that most of the current literature on understanding climate change impacts on agriculture has only focused on aggregate outcomes. It has not really focused on distributional impacts in the sense that trying to look at the distribution of a particular variable such as crop yields. Now this is important because we know climate change is going to disproportionately affect communities, and just looking at the aggregate outcome does not really help policymakers. To inform good policy and evidence-based policies, we need to go beyond an aggregate measure and look at distributional impacts. So what got me interested in the project was the second year paper, which is a required component of the PhD program here. Some of the work I'm doing in my dissertation is a direct outcome of what I already did in my master's thesis, which is understanding the effects of input use on agricultural productivity. And I focused on vulnerability because, as I said earlier, there was a massive gap in the literature in the sense that this area had not really been explored, and I went about exploring this. There are two main contributions that come out of my dissertation. First of all, it's a methodological contribution because we are looking at vulnerability in the sense of understanding how to measure vulnerability. Policymakers are interested in this because they want to target populations that are vulnerable so as to mitigate losses. My dissertation has direct implications for policymakers because we focus on two main data sets that are common in Indian agriculture. One is a district level data set, which is at a more aggregate level, and we also focus at a more individual or household level. Our findings indicate that adaptive mechanisms in irrigation and high yield variety seeds are some of the tools that policymakers can use to help these farmers overcome losses from these extreme weather events. What we also do is provide a map of vulnerability. Policymakers can look at this map and identify the regions and populations or communities that are vulnerable and then target these particular communities.